This video is going to talk about higher derivatives. Higher derivatives are found by repeatedly differentiating a function, f of x. If the function is differentiable, then the second derivative is found by taking the derivative of the derivative, and the third and fourth are taking the derivative of the derivative of the derivative. The second derivative represents the rate of change of f of x. Now that we know the power rule, quotient rule, product rule, and chain rule, we can use all of these to find the second, third, and fourth derivative of any differentiable function. So let's start with an example. If we have y equals x to the 4 minus 25x squared plus 2x, and we're trying to find the second and third derivative of this, represented by y double prime and y triple prime, we would have to start by first finding the first derivative, which we just used the power rule. So we get 4x cubed minus 50x plus 2. So now the second derivative, all we'd have to do is just take the derivative of the first derivative. We do this and we would get 12x squared minus 50, because the 2 disappears because there's no variable, and the x disappears because it's to the power of 1. For the third derivative, we just repeat this step one more time. We go, the third derivative equals 24x, because 2 times 12 is 24, and 2 minus 1 gives you x to the 1. Now that we know this, let's try one that's a little bit harder. In this example, it is asking us to find y double prime and y triple prime, or the second and third derivative of y equals x minus 4 over x. So now we know this is going to have to be a quotient rule that we're going to use. So we'll start with that, and we'll try to find the first derivative. So the first derivative, you use f prime of x, g of x, minus g prime of f of x, all over g of x squared. When you multiply all this out and subtract it, you end up with just 4 over x squared. So that's the first derivative, but we need the second and third. So to get the second and third, we do the same steps again, except this time we're going to have a different f of x and a different g of x. So in this case, our f of x is going to be 4, and our g of x is going to be x squared. So we're going to get derivative of 4 is 0 times x squared minus the derivative of x squared, which is 2x, times 4, all over x squared squared. When this simplifies, we're going to get negative 8x over x to the 4. So there's the second derivative, but now we need to find the third derivative. Third derivative, we repeat the quotient rule again. So we will get negative 8 times x to the 4 minus 4x cubed, as that is the derivative of x to the 4, times negative 8x, all over x to the 4 squared. Now when you simplify this, you get negative 8x to the 4 plus 32x cubed, and it's plus because it's a negative multiplied by a negative, all over x to the 6, which is x to the 4 squared.